Expecting you put it where the sun is, it would unwind to the circle of Jupiter, a monster, totally shaky and going to explode. They are among the most perceptible impacts of radio energy in the entire universe, conveying more energy than a billion suns. Bug Jew or unnerving crawly Jew is a red giant star. Assuming you put it where the sun is, it would connect with the circle of Jupiter. Huge, absolutely whimsical, and likewise going to explode. When we consider stars, we no doubt imagine unimportant gleaming things in the night sky. Basically, this is how we see them from down here on Earth. Yet, stars are something totally different. Indeed, perhaps one of the most prominent stars, Betelgeuse, is significantly more vital than our sun. For quite a while, this star has puzzled specialists. However, truth be told, something even more upsetting has been happening with Betelgeuse, making inspectors and other highly accomplished individuals incredibly concerned. Join us in this video as we investigate the grand new data about Betelgeuse, its coming obliteration as expected by the James Webb Space Telescope, and what this new advancement will mean for our universe and our lives here on Earth. As explained by physicist Michio Kaku, Betelgeuse is a colossal wonder, a titanic star that has charmed cosmologists for so long. A Greek cosmologist named Antonius was the first to discover it. This star is so massive that it tends to be viewed in the night sky from Earth, particularly during winter. In the event that you're into cosmology, you've no doubt seen or heard about the star. The becoming blushing orange star indicates the upper left shoulder of the Orion constellation. So, you see, this star is ancient and perhaps one of the most glorious stars in the night sky. Yet, one thing about Betelgeuse's splendor is that it doesn't remain steady. Rather, it shifts. This change is one of the star's unique properties. But it isn't the only one we ought to explore. Most of the stars you see in the night sky are far from Earth. The nearest star is 4.2 light-years away from Earth. If you're unsure how the term light-year gives a sense of distance, picture it this way. Consider moving at the speed of light for a whole year. It's been shown that light can cover a distance of 186,000 miles per second. Hence, the distance light can cover in a year is essentially equivalent to 1 light year. If you figure it out, you'll have billions of miles. So, when we say the closest star is 4.2 light years away, it means it is billions of miles from Earth. Anyway, look at this. Several stars are farther, and Betelgeuse is one of them. Betelgeuse is found about 600 light-years from Earth, so if you somehow manage to travel to it at the speed of light, it would still require 600 years. We can't move that fast, not even our fastest space rockets can. Yet, this star can still shine so brightly in our sky. If you're wondering how Betelgeuse can be so noteworthy despite the distance, it is an outcome of its unique qualities, such as size and brilliance. Betelgeuse is many times more massive than our sun. Its span is considered to be roughly that of the sun. Tragically, it appears as a disk in space when using current telescopes. While various stars appear as tiny points of light, this is believed to be an effect of the reactions at the outer layers of its atmosphere. Regarding mass, Betelgeuse weighs around 12 to 19 solar masses. A solar mass is the standard unit of mass used by space researchers. 1 solar mass is approximately 2 times 10 to the power of 30 kilograms. Specialists can't pick the exact mass of Betelgeuse, since there are no other planetary bodies orbiting around it to compare it with. Obviously, we can't measure it directly from here on Earth. At any rate, this makes Betelgeuse many times heavier than our sun. The brightness of Betelgeuse fluctuates in magnitude from size +0 to +1.6. In more familiar terms, Betelgeuse is typically brighter than our sun. No surprise, it was nicknamed a red giant. However, the brilliance of Betelgeuse doesn't remain steady. It fluctuates. This change is due to its pulsations, or in other words, Betelgeuse expands and contracts. When it grows, it becomes brighter. When it contracts, it dims. This cycle can persist for 10 to 100 days, or even much longer. An interesting property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field here is far stronger than at the normal surface. However, the downside is that these strong magnetic spots impede the flow of hot gas to the star's outer surface, making the star cooler in these regions. The fact that Betelgeuse has so many of these spots, compared to our Sun, explains why it is cooler than our Sun despite its size and brightness. The Sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and far more numerous. To give you an idea, the spots on Betelgeuse can be twice as wide as Earth. Betelgeuse also boasts a magnetic field that is typically stronger than that of the Sun. This field is the reason that, when seen through a telescope, the gases on the outer layer of Betelgeuse appear to be swirling around or bending. Betelgeuse has a surface temperature of around 3,500 K. This low temperature contributes to the low energy emitted by the star and its faint red color. Betelgeuse is a red star, but it wasn't always red. It was yellowish about 100,000 years ago, much like our Sun. Over time, the color gradually changed to orange, red, and eventually, around 10,000 years ago, it began changing into the red star we know today. This fact has led scientists to believe that the star is evolving. Betelgeuse produces many times more energy than the Sun, but it would have been a blistering contender to Earth's Sun if it weren't so far away. The fact that Betelgeuse, which is 600 light-years away, can still be seen and observed with the naked eye at night is incredibly striking. Our Sun is only 8.3 light-minutes from Earth. That's why it's so strong. If Betelgeuse were closer, we would also be able to see it during the daytime. But if it were to replace the Sun, it would consume or displace the Earth and the other 4 planets near it, due to its immense size. Even if Betelgeuse were to match the Sun in size, it would still emit more radiation. Betelgeuse, also called Betelgeuse, is an enormous star located in the constellation Orion, about 600 light-years from Earth. Its immense size is perhaps one of its most striking features. It is typically much larger than our Sun in terms of radius and could easily encompass the orbit of Jupiter if placed at the center of our solar system. This fantastic size allows Betelgeuse to appear as a disk rather than a point of light when viewed through powerful telescopes. Unlike most other stars, despite its colossal size, Betelgeuse isn't the most extreme star in terms of mass. Its mass ranges from about 12 to 19 times that of the Sun. This variety in mass estimates is due to the challenges in accurately measuring the mass of stars that lack companion stars or other objects to provide gravitational reference points. In fact, even at its lower estimated mass, Betelgeuse remains a gigantic celestial body. The brightness of Betelgeuse is another key characteristic. It fluctuates regularly over time, with its luminosity ranging from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be up to 100,000 times more luminous than our Sun. This change is attributed to its pulsations, expansions and contractions caused by internal cycles within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last for months, contributing to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a massive star, averaging around 3,500 Kelvin. This gives it a distinct red color, typical of red giant stars nearing the end of their life cycles. Like other red giants, Betelgeuse is in the later stages of stellar evolution. It has exhausted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process generates energy, causing the star to expand outward. The star's atmosphere is rich in complex physical phenomena, showing dark magnetic spots on its surface, where the magnetic field is stronger than the surrounding areas. These spots prevent the convection of heat, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains an enormous, brilliant star. However, it will ultimately meet its end in a spectacular cosmic explosion, a supernova. This is the dramatic fate of a massive star. When it runs out of fuel, it will undergo an extreme process of fusion, turning heavier elements like helium and carbon. This will cause the star to expand to potentially much greater sizes, making it one of the largest stars in the night sky before it dies in a stunning explosion, a supernova. The force of a supernova is powerful enough to disrupt an entire solar system. This event could even send shock waves through space, and it is possible that Betelgeuse will undergo such a violent end in the near future. Although this fate is not imminent, scientists are closely monitoring Betelgeuse's behavior, hoping to gain more insight into the life cycle of stars and the evolution of the universe. As Betelgeuse nears the end of its stellar life, astronomers are paying close attention to its activity. The star is expected to eventually go supernova, a catastrophic event that will result in the expulsion of its outer layers into space, leaving behind a dense core. This core could become a neutron star or collapse further into a black hole, depending on its mass. A supernova is a destructive event, but it plays a crucial role in the universe. The explosion will scatter heavy elements into the surrounding space, enriching the interstellar medium and contributing to the creation of new stars and planets. This cycle of life, death, and rebirth is a fundamental process in the evolution of the cosmos. In conclusion, Betelgeuse is not only one of the most fascinating stars in the night sky, but its impending supernova is a reminder of the dynamic and ever-changing nature of the universe. As scientists continue to study its behavior, we can expect to learn more about the final stages of massive stars and the cataclysmic events that shape the cosmos.